Greetings, math friends. We are going to look at multiplying two binomials by each other. A binomial, if you didn't know, means that it has two number parts. So when we look at this first parenthesis, we have this plus this. If we know what x is, we have a number, so we would have a number plus a number. If we knew what x is, we would have a number times a number. We still want to be able to do the algebra without knowing what x is. So we are going to talk about how to multiply these together. There's an acronym that some people like to use called FOIL. It stands for first, outer, inner, last. FOIL is meant to be a mnemonic to help you understand which terms to multiply together. Looking at the first terms, the I stands for the inner terms. The O stands for the outer terms. L stands for the last terms. When we go through this process, we have 2x times x is 2x squared. Then we have 2x times 2 is 4x. Then we have 1 times x is x. And then we have 1 times 2, which is 2. Once we have this, we see that we have like terms here in the middle, and we can simplify this expression by adding those together, leaving us with 2x squared plus 5x plus 2. This is the product. We get a trinomial by multiplying two binomials together. One thing that I find with FOIL is that it is not always easy to remember what FOIL stands for, and you may not understand which terms to multiply. The order actually does not matter. Also, FOIL is only good in the case of two binomials. If you had a binomial times a trinomial or a trinomial times a trinomial, FOIL immediately loses its value. What I like to teach is that you should look at this as double distribution. We know the distribution property is one of the basic properties for using real numbers and doing algebra. We just want to take that property, or axiom if you know it as an axiom, that we already have learned about and apply it to this situation and apply it twice. We're going to go ahead and set this equal to this. We've already done that. And then we're going to go through double distribution and watch this unfold again, only reapplying distribution twice. The nice thing about the reapplying the distribution property multiple times, it works if you have a binomial times a binomial, a trinomial times a trinomial, or any polynomial times any polynomial. Now that we've reset this, let's look at using the distribution property twice. If I hide the first term, we see that we have distribution property here, 1 times this term, 1 times this term. This is the distribution property that we've come to know. So we have 1 times x is x, 1 times 2 is 2. If we go ahead and remove blocking out this term and block out this term, we again see distribution property. I have 2x times this term and 2x times this term. We're just going to repeat distribution. 2x times x is 2x squared. 2x times 2 is 4x. There's no extra things to remember beyond the distribution property. I don't have an acronym, and I don't have a forced order. I again need to look to make sure that I don't have any terms that need to be brought together like terms. I do. We know that we had like terms before. We have like terms again. This x and the 4x are going to be brought together to be 5x. We have kind of a standard form or a general form for quadratics. Or for polynomials in general, we like to start with the largest exponent and work down to the smallest exponent. So we're just going to put that general form into play. 2x squared plus 5x plus 2. We're just rearranging this because of the commutative property, and we again get the result that we had before. So the order doesn't really matter. Because it's addition, we have the commutative property of addition. If we would reverse these binomials and multiply, we would still get this because this is multiplication of real numbers, and we have the commutative property of multiplication. Hopefully this has been helpful in understanding how to do a binomial times a binomial. Check out these problems on the screen. Go ahead and pause, try the problems. The solutions will follow. Cheerful Calculations.